Now that you've watched the demonstrations, let's talk about what we saw. So let's talk about the first one with the syringe and the balloon. We were able to see that as we increased the pressure inside the syringe by pressing the stopper with the syringe closed, we increased the pressure inside it right here. And the effect of that on the little balloon of gas is it got smaller. And so as pressure increased, we saw volume decrease for the gas. And then when we brought that syringe handle back, we were able to see the gas inside it, the balloon expand. So as the pressure then decreased, our volume increased. And so we can see that we have a relationship between pressure and volume that is inversely proportional. And so I could say that as my pressure changes, I expect to see the opposite change happen in volume, or pressure is proportional to the inverse of volume. All right, looking next at our second demonstration, we saw that we had an egg inside of a flask, and the water was, the air inside of the flask was heated with a flame. And when the flame went out, the hot air, which was allowed to escape, and an egg was sitting on top, was able to pop out. So the egg sitting on top, and as the flame goes out, the temperature of the air inside, without the flame present, is going to decrease. So as that temperature decreased, the pressure inside the flask changed such that the egg was sucked into it. That means the pressure was decreasing. And so as the temperature went down for our gas, we saw the pressure also go down. To get that egg then that's in the flask that doesn't fit coming out of it, but has kind of, it's a little expandable. To get it out, the way it happened is we heated up the gas inside the flask. And when that happened, it increased the pressure, increased the pressure, increased the pressure, increased the pressure until the egg was popped out. And so as temperature increased, we saw pressure increase. So that means when temperature goes down, pressure goes down. When temperature goes up, pressure goes up. We can say that temperature and pressure are proportional to one another. We expect one to change in the same way the other does. Now, for our third one that we looked at, it was related to the number of moles of gas. Now, the first one, we increased the moles of gas by generating carbon dioxide through a chemical reaction. And we kept the pressure constant by putting a balloon over the flask. And in doing that, the gas was able to expand into the balloon. And so it expanded and expanded, and the balloon got bigger and bigger and bigger. And so the volume of the gas, as we added more moles of gas, the volume increased. And so we saw that volume increased as the moles of gas in the system increased. Now, when we did that in a rigid container, a film canister, then we had a constant volume. And that meant that as that CO2 was produced by the chemical reaction, instead of the volume increasing, we saw the pressure increase, and it built up and it built up until it popped the canister off the lid. And so as the moles of gas increased, the pressure increased. So that means we can pull a relationship out of this too. That our moles of gas will be proportional to the volume, and the moles of gas are proportional to pressure. So as the moles of gas increase, so did the pressure and so did the volume. And so we get two more of these relationships out. And these relationships make the foundation of our variety of gas laws, which are mostly just a comparison of two variables and the relationship between them when we are observing a gas. Now we can take these relationships and combine them and craft an equation that allows us to make predictions and calculate the volume, pressure, temperature, or volume, pressure, temperature, or number of moles of a gas for any system if we know information about the other pieces. And so we'll talk about that next.